All right, so standard 5 is all about box plots. So these are the box and whisker plots that you guys have saw years ago, probably in middle school. So the data sets below compare the overall grades of students in two different stats classes after the mid-year exam. So we can see the grades there. Create stacked box plots for these two data sets. Remember to check for outliers. Which class has performed better? Cite at least one statistic in your answer. So in order to create box plots, you need the 5-number summary. The 5-number summary is the minimum, Q1, the median, Q3, and the maximum. In order to get those values for these two data sets, you should put them in your calculator. So you should put class A maybe in L1 and class B maybe in L2. And then you're going to go stat, calc, one variable stats for each of those two lists. And it will spit out the two different 5-number summaries. So get the two different 5-number summaries. You got to check for outliers and then try to create your box plots. Or I will walk you through it a little bit in this video. Let's check it out. Okay, so at the bottom of this slide, you can see that I have the 5-number summary for the A class and the B class. So we can compare the minimums, the Q1, the median, the Q3, and the maximums. I also calculated the IQR. The IQR is just Q3 minus Q1. And I used the formulas for the lower boundary and the upper boundary for outliers in order to figure out those boundaries. And it turns out that for class A, 99 is considered to be an outlier. For class B, 41 is considered to be an outlier. So now it's time to actually create the box plots. Okay, so here's our box plots stacked on top of each other. A couple things to note. I did label the x-axis. I have an x-axis for both of the box plots. It's the same x-axis, and the box plots are stacked directly on top of each other. The vertical lines in each of the box plots are just positioned at the minimum, Q1, median, Q3, and maximum, going from left to right. And the only exception to that is the outliers. So for class A, you can see the asterisk that I put for the outlier at 99. And the quote-unquote maximum that is not an outlier, if we go back to the data set, for class A is 87, because 87 is the biggest non-outlier in class A. So that vertical line that you see in the A box plot, that's like all the way to the right, that is at 87. And then for class B, again, we have a low outlier at 41. The quote-unquote minimum, it looks like it's just below 70, and that's because the lowest non-outlier is 69 for class B. And then we have our Q1, median, Q3, and maximum all positioned as expected for class B. So that is my stacked box plot drawing. Now going back to the actual question, which class has performed better? Cite at least one statistic in your answer. So there's a lot of different ways that you can explain this. I think the easiest thing to do is just to pick one of the values in the 5-number summary and compare it directly. So for example, if I was to compare the third quartile for these two data sets, clearly for class B, Q3 is greater than Q3 in class A. I could compare the medians as well, in which class B would win. If I compared Q1, class A would win. But it's up to you. You can pick and choose really any of those in the 5-number summary. Something else to look at is the spread. The B data set is a lot more spread out than the A data set. So the kids in the B data set are getting a real wide variety of scores, right? I mean, those scores range from, 69 to 100, whereas essentially everybody in the A class was scoring between 75 and like a high 80, right? So it seems like the A class was a lot more consistent than the B class was, right? So, and this is a fun data set too, because if you actually calculate the 5-number summary and all the summary statistics for this data set, one thing that you might notice is that the mean is actually the same for both of these classes, right? So if the teacher was just looking at the averages, these two classes actually have the same class average. But there's obviously a lot more going on behind the scenes. That's one of the reasons that we use more than just the mean to talk about data. And that is standard 5 box plots.